Welcome back to the Scilife Academy and another training session. This one is about aseptic processing, a critical step in the production of sterile drugs, vaccines, and other biologic products, which requires meticulous attention to detail and strict adherence to regulatory standards. Even a tiny contamination in the manufacturing process can compromise the safety and efficacy of the final product, leading to serious health consequences for patients. In this course, we will look at best practices to minimize the contamination in aseptic processing. We will cover the importance of training, gowning, environment, premises, equipment, sterilization processes, and environmental monitoring. We will also cover a high-level introduction of single-use technologies. So let's get started. To minimize contamination in aseptic processing, some key strategies are needed. Let's see a general overview of the most important ones. In clean environments, personnel are the primary source of microbiological contamination. Human contamination can be minimized by providing comprehensive training to all personnel involved in aseptic processing, including gowning techniques, aseptic techniques, behaviors, and hygiene practices. Training should be ongoing and periodically refreshed. You must ensure that personnel wear appropriate protective clothing, including sterile gowns, gloves, and face masks. Gowning should be performed in a designated area using proper procedures and under strict supervision. The use of isolator technology minimizes operator interventions in aseptic processing areas, resulting in a significant decrease in the risk of microbial contamination. The aseptic processing area should be designed to minimize the risk of contamination. Regulations require aseptic areas to be ISO Class 5, Grade A, or Class 100. This area should be kept clean and maintained under positive pressure to prevent the entry of outside air. Whenever possible, Grade A areas should be designed so that all operations can be observed from outside to avoid unnecessary entry by supervisory and control personnel. All exposed surfaces should be smooth, impermeable, and unbroken to minimize the shedding or accumulation of particles or microorganisms. Surfaces, pipes, and ducts should permit the application of cleaning agents and disinfectants without any uncleanable recesses. While pharmaceutical manufacturing plants have installed fixed piping for fluid management made of stainless steel, medical drug product manufacturers are increasingly changing their setup to single-use technologies. We'll discuss the benefits of single-use technologies later on. Contamination should be minimized using aseptic processing equipment. For example, air and filtration systems, water treatment, and others should be validated and maintained in accordance with appropriate procedures. Whenever possible, equipment should be chosen so that it can be effectively sterilized by steam or dry heat or other methods. They should be designed and installed so that operations, maintenance, and repairs can be carried out outside the clean area. All materials and components used in aseptic processing should be properly sterilized. This includes the use of sterile media, sterile components, and proper cleaning and sterilization of equipment.